which are the kernels going to be helpful to understand the convolutional neural networks. So we're going to use this under kernel nature, and it maybe works out well for some different data sets. It may not be works well for the some other different data sets, but it will be useful some cases. You can whenever you want to play around with the any kernel, you can go with the domain based kernels. Domain based kernel, basically you have to learn what are the different images you had. According to that, you have to be focused on how to build the kernels. So this is somewhat depth knowledge we had to be understood from the domain knowledge. So basically what we are going to do, we are going to be directly call the convolutional neural networks and passing through some of the input shapes, okay, and also along with the activation functions what we had, and along with the optimization functions, optimization algorithms. So for that, most of the people will use direct functions. Few of the people use the customized kernels along with the customized kernel. You can just customize convolutional layer. At that time, they may be used as a domain-based kernel. Yeah. So let's go and understand what exactly the padding does and why we are using this. So the padding, basically we are going to be used. Suppose you have an image. You have an image kind of this. So this is some human being, you can say human being picture. It may be having the bandwidth to, or you can say it may be having to maximize this image as much as possible. But what will happen, it somehow you are missing this kind of the nature. You are missing this kind of the nature, and you are missing this kind of the nature. So for this, what you have to do, you have to extend this matrix somehow. You have to extend this matrix somehow. So I'm just adding some padding kind of the thing, or you can say I'm adding some the new other information with respect to this for all the edges, I can say, to learn more about our edges and to learn more about our image patterns. So for that, I will add for one, if suppose I will add one layer for top and bottom and also the left and right, I will call it as one padding. If I add two more layers kind of the thing with respect to all the different edges, I will call it as two padding. So if I add three layers, I will call it as three padding. So like that is going to be, you can also see this image. This is a one padding or first padding according to the image what we had. So I'm just passing the zeros values so that we cannot get rid from the whatever the values we are going to be get from this, you can say from these images. So just passing the zeros value so that we can understand how does the padding going to be helpful. Without padding also, how does that going to be helpful. So without padding, what will happen, you may be miss some of the patterns according to multiplying with your kernel. So we are just multiplying whatever the input. This is the input image, right? This is the input image, this is a kernel. So we are just applying to get the output. So this is the output. So in terms of currently it is in the 4x4. So you have 3x3 and 2x2. So to multiply any kind of the thing, you can cross check with respect to, we have around, I think 5x5. Yeah, 5x5. So eventually what will happen, you want to be get in terms of the 4x4 or 6x6, you can say 6x6, or maybe the 5x5. Depends on the requirement of the output. You want to be showcased as that much of resolution to get into the classification task or any kind of the task you want to perform. So depend on the task, you can directly apply the padding that will be enhance your you can say the features to understand much better to classify the things. Along with that, you can pass the zeros values whatever the padding does with respect to the input image. So you're going to be multiply. Let's take this image. So you can see here we cannot multiply directly. If you just understood the matrix multiplication concepts, if suppose I have an array called, or I have a you can say a matrix called x cross n, and also that I have another matrix called n cross x2. So if this is the case, I will get the eventually the output results as x and x2. So because this is going to be matched, right? At the time you're going to be column and also the rows going to be massive, then only we are going to be multiplied together. Hope you know these concepts. So if you just multiply these things, we cannot do that because it having 5 cross 5, it having the 2 cross 2, right? It having the 2 cross 2 matrix. So at that time you cannot do that. So for that we are going to be take the portion of this. You can see further you're going to be take the portion of this is a 2 cross 2 matrix, this is a 2 cross 2 matrix. So then it is going to be satisfied with respect to the columns and also the rows. So then you can multiply with respect to this value. You already know, right, how to do the matrix multiplication. So for that you just multiply it with the horizontal with the vertical, horizontal with the vertical, like that you can multiply. So eventually you get the value corresponding to the output results you had. Similarly you can take the next portion like this and multiply with respect to the kernel, and similarly you can take the next portion and multiply it with the kernel. You will get this value, you will get this value, and similarly you can do the same things for all the different portions you had in the input images. So for that what you are going to be learn, you have added a padding kind of the sequence with respect to the each and every edges, so that you will eventually get at the end or at the input images consist of different values. So this will going to be helpful to identify your input image is dog. So I mean specific this you can say specifically known to corresponding to the convolutional is basically it's going to be learned with respect to the kernel or filter, we can also call it as, with respect to multiplying with your input image you're going to be get as a output results. And one more operation is called stridings. So go and detail discuss about the striding. So why we are using striding means, if suppose I have an image, yeah, so if suppose I have an image like this, you have an image with it's not I'm not going to be draw somehow with respect to the 3D kind of the thing, but let's suppose assume kind you can say some person is there, yeah, some person is there like this is some high with respect to the 3D kind of the image, you can imagine maybe. Yeah, so he is you can say he is he's looking at this side. Okay, he's looking at this side, and yeah, this is somehow we can draw some image. So you want to know about this person, how does it's going to be rotated, and it's going to be stride in terms of our original format. So I want to look at this way, my way. If you go and see your screen, how does you are looking, you are looking like this, right? You're looking like this. So I want to know about in terms of in this way to in this way. So I'm just changing my direction with respect to apply some kind of striding nature. So not only this example, you can take any other example called maybe east west kind of the thing. So we want to be stride somehow to shift some of the you can say cells. So if I going to be check out this kind of the image, what will happen, you can see. So if you're aware about any kind of the blur nature, so what you have to do, you just blurring, that means you're just shifting few of the pixels into some format, right? Fixing into some of the format so that it's going to be blur your background. So similarly we are going to be do the same thing. So whatever the input image we have, we are just avoiding into somewhat, you can say somewhat rotation kind of the thing, you can say. But it's how somewhat going to be change the pixel size and also the size of the images, you can say size of the images somewhat. So at that time you're going to be used as a strike nature. You want to be strict, you can say you want to be shift in terms of the two pixels, or you want to be shift in terms of the 1 pixel. So according to the knowledge of striding is, we are going to be shift who which pixels you want to be shift, or which how many pixels you want to be shift at that time. So you can see this is the input image while applying the padding also. So this is the input image, we just applied the padding, we just now learn, and we are going to be apply the striding also to get some of the steeringness of the images. So for that, what we had to do, at the time we taken as this pixel, right, to calculate our output results. So what we had to do, you want to be shift towards the two shifts, you can test two pixels, two strides, you can say. So two pixel are going to be shifted. This is first pixel, this is second pixel. I shifted to the two pixel with respect to the two input cells what we had. So this I shifted with corresponding to some of values. So what will happen, I will calculate these values with my current value or whatever the kernel results what we had. Similarly, I will shift this into the two times. So I will take this one and I will calculate with respect to this. Similarly, I will shift this one like this one. So I will take and I will calculate this one. So for that, you can shift this one